Hope you all are good and doing well for the preparation of Pure Mathematics 3. Guys, today I'm going to discuss with you a few challenging questions based on modulus. The first one is over here. Question states solve the inequality x plus 1 over x minus 1 modulus less than 1. Here we know the properties that modulus of a over b can be written as modulus of a over modulus of b, right? So with the help of this property, we can write x plus 1 modulus over x minus 1 modulus less than 1. Now here you can see in the denominator we have x minus 1 in modulus. The entire term is in modulus. So whatever be the values of x, the result comes to be positive because of this modulus. So in such cases, whenever in the denominator of inequality, if you have the entire term in modulus, then you can do the cross multiplication because it doesn't affect whatever the value of x you will replace, the result will be positive. So we can do the cross multiplication simply here. So I can write like this is less than modulus x minus 1. Now the same case, we have modulus on either side of inequality. So you can do the square property over here, like taking square on both sides, we will get this and this, and this will be with out of modulus x plus 1 whole square x minus 1 whole square. So you can expand it, x square plus 2x plus 1 x square minus 2x plus 1. If you bring the right hand side towards the left hand side, we will see x square plus 2x plus 1 minus x square plus 2x minus 1 less than 0. So here this goes, we get 4x is less than 0. So x comes to be less than 0. That is the solution point. Now we can check it by substituting in the original function. So we can do the check over here. We can check the result, either x is less than 0 or what. So original function is like this, less than 0. So you can replace x with minus 1. So it means minus 1 plus 1 for x is equal to minus 1, because it is less than 0 over minus 1 modulus is less than 0. So 0 by minus 2 modulus is less than 0. 0 modulus is less than 0, not 0, it's 1 here, sorry. This side is 1, as you can see. So 0 is less than 1, which is true. So final solution is true for all x less than 0, right? I hope it is clear. Let's proceed to next question. Yes guys, in this question we have solved the inequality modulus of x plus 1 whole divided by modulus of x minus 1 less than 1. Here you can see whatever the values of modulus x you will replace here. If it is it can be positive or negative. Yeah. So because if you take x 0.5, then denominator becomes negative, and even x minus 0.5 is become negative. So in such cases, whenever in the modulus question denominator of a function is less than 1, or it can be negative, denominator can be negative by replacing different values of x, then we can't do the cross multiplication here like we did before in such questions, because in the above question here, you can see whatever be the values of x you will replace, because all the function in denominator is in modulus, the result will be positive. So we can multiply like the cross multiplication and we can solve it easily. But whenever the scenario is like this way, that in you are not sure either the value will be positive or negative, both options can be expected for replacing the values of x, then we can't do the cross multiplication. But surely in such cases we can multiply either side of inequality with the square of the denominator term. Like here you can see this is numerator and this is what denominator, and square of denominator can be multiplied on either side of inequality, right? Here you can see 1 will be cancelled and we will get modulus of x plus 1 times modulus of x minus 1 less than modulus of x minus 1 whole square. And here you can see we can apply the identity a plus b, a minus b, that is a square minus b square, and here a plus b whole square x mod square minus 2x mod plus 1, right? And of course bring the terms on one side. We can see this minus 1 minus mod x square minus 2x minus and plus once becomes here minus 1 less than 0, and this goes, we get 2 mod x minus 2 less than 0, or we can say 2 mod x less than 2. This is equivalent or equivalent sign. So now even we can divide with 2 on both sides of equality. You will see we get x mod is less than 1. Now as the property states, this will be plus minus x is less than 1. So x can be less than 1 or minus x can be less than 1. That means x can be greater than minus 1. So we have these two options. Now you can check and finalize your answer, like check. Here we can make a check. Original function was mod x plus 1 over mod x minus 1 less than 1, right? So first for x is less than 1, so you can replace it what 0, because there is a less than 1, or any other number. 0 plus 1 over mod 0 minus 1 less than 1, we get 1 over minus 1 less than 1, that is minus 1 is less than 1. This is true. So it means one of our option is x is less than 1 is true. This is true. Let me write it clearly. It's true. True option for this case when x is less than 1. Or other options, mod x when you replace for x is greater than minus 1, again you can replace it 0 or 1 or any other number. We try to start with the closest, so with 0 what comes is 0 greater than minus 1. Yeah, 0 is fine. 0 plus 1, again the same values you will see, again it will be true. minus 1 is less than 1, so it is true. So final answers are either x is less than 1 or x is greater than minus 1. I hope it is clear. Only the thing which you need to keep in mind, this is the second case is very important. When we can multiply the square of the denominator term on either side of inequality, only when you are not sure about the denominator result, either it will be positive or negative. Both options if you have, then you can multiply both sides of inequality with the square of the denominator. This is the property. I hope it is clear. Okay.